In this video, we'll take a look at how to find the domain of a function algebraically. I have a statement written here. The domain of a function is all real numbers, which is abbreviated as negative infinity, comma, infinity, unless x is in a denominator or x is under a radical with an even index, such as a square root. Now we'll take a look at these two special cases, case 1 and case 2, in a minute. But for example, let's look at a few functions here. Let's say that a function is f of x equals 4x squared minus 3x plus 7. You're going to ask yourself, is there an x in the denominator, or is there an x underneath the radical with an even index? This problem does not have a denominator, and it does not have a radical. Therefore, the domain for this function is all real numbers, negative infinity to infinity. Or you could write down the abbreviation for all real numbers, which is also this symbol right here. The next function, let's say, is g of x equals x plus 2 divided by 5. Okay, now to find the domain for this function, ask yourself, is there an x in the denominator? Well, the denominator is right down here with the 5, so no, there is not an x in the denominator, and there is not an x underneath the radical. There is no radical in this problem. So the domain will automatically be all real numbers. Okay, what about another function? H of x equals the cube root of x plus 1. All right, now we do not have a denominator in this problem, but we do have a radical. But notice that the radical is a cube root, and that is an odd root. So it doesn't have an even index. Actually, this problem has an odd index. The index is actually the root that we're looking at. So therefore, number 2 is not satisfied. It is not an even index. It's an odd index. So the domain will be all real numbers. Now let's take a look at some problems where we actually have to do some work, where we have an x in a denominator and an x underneath the radical with an even index. Example. We want to find the domain of the function f of x equals 4x minus 1 divided by 2x plus 4. Okay, now obviously this is our denominator and there is an x involved. Okay, so this is our special case 1, an x in a denominator. The first thing you need to do is set the denominator equal to 0 and solve for x. So our denominator is 2x plus 4. I'm going to set that equal to 0 and solve for x. Subtract 4 from both sides. 2x equals negative 4. And then divide both sides by 2. X will be negative 2. Now this number is not in the domain. This number is not valid with the function. And I'll show you why right now. If I take negative 2 and I plug it back into the function, we would find f of negative 2, and that would equal 4 times negative 2 minus 1 divided by 2 times negative 2 plus 4. If we do this math, we get negative 9 in the numerator divided by 4. This is a negative 4 plus 4, 0. Anytime we're dividing by 0, the function is undefined. So by plugging in negative 2 for the input, there was no output. That's why this number does not work with the function. It's not valid. So negative 2 is a number we're looking for to take out of the domain. Now, in order to write this in interval notation, we need to think of the number line. The number line has positive numbers on the right and negative numbers on the left. Now, at the end of the number line, we would have negative infinity on the left and positive infinity on the right. And infinities used quite a bit, so I always put the infinities on my number line. Now, the number that we found that was invalid was negative 2. So at negative 2, I'm going to put an open dot on the number line since it's not valid. However, every other number works, so in order to illustrate that, I'm going to draw an arrow to the left showing that all these numbers are valid, and an arrow to the right showing that all these other numbers are valid. The only number that doesn't work, like we said, is this negative 2, and that's why we have an open dot there. So when we write interval notation, we start on the left. This arrow is going to negative infinity, and this arrow comes up to the open dot at negative 2. So that's where it stops, and I'm going to write negative 2 there. So this interval represents the left side of the number line. Now we need to represent the right side with this arrow. This arrow starts at negative 2, and it ends at positive infinity. And between this, we need to use a symbol called a union. It means and. So this would be our final answer for the problem, written in interval notation. Notice that we use the open dot because the number did not work. It was not valid. And actually, you can see here that we took out negative 2. Let's go work another problem that involves a denominator. I'm going to go to the next page here. Our next problem we want to find the domain of is f of x equals x squared plus 3 divided by x squared minus 3x minus 10. Alright, so on this problem, remember the rule. If we have an x in the denominator, then we have to set the denominator equal to 0. Now this problem is a quadratic. It has a squared for the highest power, and when we have that, we need to factor. So we need to ask ourselves, what two numbers multiply to the last term negative 10 and also add to the middle term negative 3? For the two numbers that multiply to negative 10 and add to negative 3 are negative 5 and positive 2. So those numbers will go in our factors. Doesn't matter which number you put in first. I just wrote the negative 5 and then the 2. Now when we have the factors, we need to set each factor equal to 0 and then solve for x. So x is 5 and x is negative 2. These numbers are not in the domain, These are invalid numbers with this function. So we need to think of the number line to write the interval notation. I'm going to put the negative infinity on the left, positive infinity on the right. Okay, so at negative 2, we have an open dot, and also at 5, we would have an open dot. Next, I'm going to draw the arrows representing all the numbers that are valid. So all these numbers going to the left are valid. All these numbers here in the middle are valid numbers. And then these numbers over here on the right are valid. So notice that we have 1, 2, 3 intervals here for this problem. Let's look at interval 1 and how to write that. This arrow goes over to negative infinity, and it stops at this open dot at negative 2. There's the first part. Now the second interval goes from negative 2 over to positive 5. And the third interval goes from 5 to infinity. This is the answer for the problem in interval notation. Notice that we took out negative 2, that was invalid, and we also took out the number 5, that was invalid as well. Our last problem will deal with the second case, and that's where we have a square root. So we want to find the domain of f of x equals a square root of x minus 3. Notice that x is underneath an even index. The square root is always an even index. So the idea here is to set the expression under the radical greater than or equal to 0 and solve for x. The number underneath the radical must always be a positive number. That's why we're setting it greater than or equal to 0. 0 is valid as well. So the expression underneath the radical is x minus 3. We need to set that greater than or equal to 0. Solve for x. Add 3 to both sides. So x is greater than or equal to positive 3. These numbers are valid in the domain. All numbers 3 and greater. Now if we think of the number line here, at 3 we would have a closed dot because x can equal 3. So if it's an equals, we would always have a closed dot. And greater than 3 is over on the right. So these are the numbers that would be valid with this function from 3 to infinity. Around 3, I'm going to use a bracket. A closed dot always needs a bracket in interval notation. Infinity always has a parenthesis around it.